Today we're going to divide radical expressions. The quotient property for radical expressions says that for any numbers a and b, where a is greater than 0 and b is greater than 0, the square root of a over b is the same as square root of a over square root of b. So what this means is for square root of 48 over square root of 3, it's the same as square root of 48 over 3. And so we could divide this first, and we would get the square root of 16, which is just 4. But in example 2, we have the square root of 45 over 4, which might be easier if we just simplify to square root of 45 over the square root of 4. The square root of 4 is 2, and then we can find the square root of 45, which ends up being 3 square root of 5, and we have that divided by 2. This is as simple as this one will get. If I want to rationalize the denominator, this means that I want to remove any radicals from the denominator, the lower part of the fraction bar. So, for example, to simplify the square root of 5 over 3, that's the same as the square root of 5 over the square root of 3. I want to multiply by the square root of 3 over the square root of 3. This is just a 1, so I can multiply by 1 and not change my original answer. So then I've got the square root of 5 times the square root of 3 over the square root of 9, which is just 3. So then I got the square root of 5 times the square root of 3 over 3, which is the square root of 15 over 3. The square root of 15 doesn't simplify, so that's my final answer there. To put something in simplest radical form, you must know that there's no perfect nth power factors other than 1. No fractions in the radicand, and no radicals in the denominator. Here are some examples. We're going to simplify the first one to square root of 5 over square root of 4. The square root of 4 is 2, so we have square root of 5 over 2, and that's it. The next one, we've got 20 over 2, which is just 10, and then the square root of 8 over 2, which is 4. 8 over 2 is 4. And then the square root of 4 is 2, so it's just 10 times 2, which is 20. Here are a few more examples. So to get the square root of 2 out of the denominator, I'd multiply by square root of 2 over square root of 2. That gives me 5 square root of 2 over 2 square root of 4. The square root of 4 is 2, so I've got 2 times 2 in the denominator, which is 4. And my problem is simplified because the square root of 2 cannot be simplified anymore. For example 4, I'm going to split this so that it is 4 square root of 5 over the square root of 7. This 4 can do that because it's like 4 over 1. So I put my 4 in the top part of the fraction bar and my 1 in the bottom. And we don't write the 1, so it's kind of just invisible or implied there. To get the square root of 7x out of the bottom, I multiply by square root of 7x on both the top and the bottom. That gives me 4 square root of 35x over the square root of 49x squared, which simplifies to be 4 square root of 35x over 7x. And since the square root of 35 does not simplify anymore, I am finished. Now, there are conjugates, which are binomials of the form a square root of b plus c square root of d, and a square root of b minus c square root of d. This is where a, b, c, and d are all rational numbers. So for example, if I have the square root of 5 plus 6, the conjugate of this is the square root of 5 minus 6. And if I have 3 minus 2 square root 2, the conjugate is 3 plus 2 square root 2. So what would the conjugate of 2 square root of 7 plus 3 be? All you need to do is change the sign, and we get 2 square root of 7 minus 3. The product of a conjugate is a rational number. Therefore, we can rationalize the denominator of a fraction by multiplying. So to rationalize the denominator, we want the square root of 3 out of the bottom. So we do this by multiplying by its conjugate. Square root of 3 plus 5 over the square root of 3 plus 5. Now when we do this, again, we're using the distributive property twice. So square root of 3 times the square root of 3 plus 5 times the square root of 3 plus 2 times the square root of 3 plus 2 times 5. Now the bottom, the way they get this bottom down here is square root of 3 times square root of 3 plus 5 times the square root of 3 minus 5 times the square root of 3 plus 5 times 5. So these middle terms right here, they cancel each other out and you're left with 3 squared minus 5 squared. So when you simplify all of this, you end up with 3 plus 7 square root of 3 because these terms in the middle combine, plus 10 because these 2 times 5 is 10, over 3 minus 25 because the square root of 3 squared is 3 minus 5 squared, which is 25. Then we combine the 3 and the 10 and get 13 plus 7 square root of 3 over negative 22. And that's our final answer. Alright, another example. Again, to rationalize the denominator, we're going to multiply by the conjugate. So we're going to multiply this time by 6 plus the square root of 5 over 6 plus the square root of 5. We're going to multiply out the top. 1 times 6 is 6. 1 times the square root of 5 is square root of 5. 2 square root of 5 times 6 is just 12 square root of 5. Remember here, outsides with outsides, insides with insides. There's nothing to multiply on the inside here, so it just stays square root of 5. Then we multiply 2 times square root of 5 times the square root of 5. Square root of 5 times square root of 5 is just 5, so it's 2 times 5, which is 10. That's where this number is coming from. Now when you multiply by a conjugate, the middle term disappears, and that's why you can quickly go to 6 squared minus square root of 5 squared, which gives you the 6 plus the 10 is 16. 1 square root of 5 plus 12 square root of 5 is 13 square root of 5. And 6 squared is 36 minus 5 is 31. And that's where that answer comes from. I know this was a lot, so if you have questions, please write them down so that you can ask in class tomorrow. Don't forget to take really good notes on this one. You needed to write down the examples because you're going to need them for class tomorrow. Also, don't forget to answer the questions afterwards.